Welcome to Homework Lib.
Hi, so for this question, essentially what we're going to get is that the heat that is coming from the reaction, it is going to change the temperature of the water. So we have 100 grams of water. We are going to have a change of temperature that is going to be equal to 24.9 degrees Celsius minus 14.8 degrees Celsius. This is going to be a change of 10.1 degrees Celsius. So we apply this into the equation for the amount of heat that has been generated. The mass is 100 grams. The heat capacity of water is going to be 4.18 joules per gram per degree Celsius. And next up, we're going to simply multiply it by the change of temperature, which is 10.1. This is going to give you a value for Q equal to 4,221.8 joules. So now this reaction comes from the reaction of 0.43 grams of calcium in its metallic form. We know that this reaction is going to be exothermic, so the heat absorbed by the water it's equal to minus the heat coming from the reaction. And that heat coming from the reaction is the delta H of the reaction directly. So, in order to know in joules per mole, what we need to do is a calculation of how much moles of calcium does this correspond. So, the atomic mass of calcium is equal to 40 grams per mole. So, 0.43 grams of calcium. 1 mole of calcium corresponds to 40 grams per mole, as I mentioned, 40 grams. This is equal to 0.01075 mole of calcium. We know that the delta H for the full reaction is going to be equal to minus 4,221.8 joules. So the specific one, dividing this value by n, we simply need to divide by the amount of mole that we had of reaction. So the result that we get is 392,725.6 joules per mole of reaction. Let's convert this to kilojoules, simply divided by 1000. So this is 392.725.6 kilojoules per mole. And that is all for this question. This is the molar enthalpy of reaction. Sometimes I use like a small hat to get it, right? And this is the delta H of the reaction divided by the amount of mole of reactants that we have. And that would be all. Thank you very much.